The famous conference occurs normally in January here on a wonderful location next to the beach. We're a great community with great peer networking, several events. We typically meet on the fourth Wednesday of each month, and there's 70 to 90 of us enjoying great talks and great networking. And we have wonderful speakers that we're fortunate to have come visit us and share their knowledge and experience with us. I'm very fortunate to have a great group of people with me on the board of OWASP LA, and you can see them here. And I want to thank them all for their efforts and everything they do to help make events like today possible. Hats off to all you gentlemen. Our next meeting has an old-time friend and a long leader in the field. Jeremiah Grossman will be talking about the future of asset discovery, and then that will be June 24th, also at 11:45. Please do go to our meetup site and RSVP, and we're looking forward to having Jeremiah come back. He's out in Hawaii, but he doesn't have to travel, so he's happy with that. And you know, we try to do our best with our social media presence. We try to give good content to folks to help you with the things that you do. And you can, obviously, Meetup is the way we stay abreast of our events. So we hope that you are signed up for that. And on LinkedIn, again, we share interesting posts. We share information about OWASP and AppSec Cali and about our meetings. Facebook, we have a group, and we're on Twitter as well, and we're even on Instagram. So please do connect with us, share our interesting posts to try to increase the breadth of our reach. Again, one of the important goals for OWASP is to spread the word to as many folks in the development and security community as possible, so we can approach that golden, hopefully reachable goal of secure coding and development. What we keep trying, and that's what we want to do. And if you share, then you're doing your part. So please do connect with us. And if you want to learn more about OWASP, you can go to owasp.org. A lot of information. If you are a vendor who's watching us today, you could take advantage of a great opportunity to get your branding out there for everybody. Take a look at us. We're on Eventbrite, and there's information about how you can sponsor and help grow OWASP, and at the same time, potentially help grow your business. We're all kind of stuck in the house, although there's a little bit of loosening of restrictions. But now is a really good opportunity, since many of you are not commuting, to catch up on the talks from AppSec California. There were 4 concurrent sessions, so the odds are you did not see 75% of the content of the conference. So it's all recorded. We recorded every one of the 4 sessions over 2 days. Now would be a great time for you to watch the ones that you missed. And if you didn't make the conference, then you can watch everything. It's really excellent quality video, great sound. So you'll get a lot of knowledge from these experts who took the time to come on out. So please do. If you just go to YouTube and look and search for OWASP, if you search for AppSec California, you'll find our channel with a lot of great content. So now it's time to get our main feature of the day online with us all. Michael Howard is going to be talking about 5 things you probably didn't know about Azure Keyvault. This should be a great session. We're going to go until approximately 1, and we'll stop about 10 minutes early, so everybody can put their questions in. And we would like to encourage you to do that. Before I say goodbye, I have the pleasure of introducing the founder of OWASP Los Angeles, Cassio Goldsmith. So Cassio, welcome.
Thanks so much, Richard. Always a pleasure to be here. Always a pleasure to work with you. And today's speaker is somebody who personally I've been trying to get to speak at this organization for the last 10 years. Michael Howard is a senior principal security architect at Microsoft. And today he has been mainly working on designing and implementing large-scale secure Azure solutions. Michael has been at Microsoft for the last 28 years. He was the lead application security architect for Rio 2016 Olympic Games, which were hosted on Azure. Michael is also known as a luminary in our field and also a great guy to work with. I can attest with that. We did write papers together in the past. And he's also known as the author of many of the most best-known books in application security. Some of them are the 24 Deadly Sins of Software Security, Microsoft STL book, which for a lot of companies was the book that ignite their companies to do secure development lifecycle. Writing Secure Code, which is a pretty thick book on Windows security in specific and all the tricks with the registry and C++ Win32 language. And not to forget the Secure Code for Windows Vista, which is another book that Michael wrote. So the speaker is about to join us, and I think we will need to wait a couple more minutes.
I'm on, Cassio.
Oh, awesome. I didn't see your, I didn't recognize your name. So
no, I'm on.
Yeah, without further ado, Michael Howard, thanks for being with us.
Hey, thank you. Thank you very much, Cassio. Hey, it's been a long time. Hey, don't tell him about the 10 years, man. I mean, I'm not that bad. But yeah, it's been a little while. Let me just get my presentation up and running. So I hope everyone's doing well. Everyone's keeping well. Let me know if you guys can see my. Oh, of course, it does that usual trick. Let me put on a different slide, on a different screen. There we go. There we go. All right. Can everyone see my slide deck?
Yes.
Fantastic. Hey, so thank you once again, and Cassio, thank you again for the invite. I really appreciate it. Let's just hope the next time isn't 10 years. Happy to talk about all things security. Yes, so as Cassio mentioned, I mean, my background over the last few years, I've been almost exclusively on Azure, helping customers deploy, sensitive operations, sensitive payloads and workloads onto Azure. Right now, I'm working on a massive healthcare one to do with COVID-19. I'm also working with a reasonably large engagement involving the Pentagon, but we'll just leave it at that. So yeah, lots of good stuff going on in Azure around security. And one of the backbones of just about every solution that I've ever worked on in the last few years in Azure has employed Keyvault in one way, shape, or form. And so really what I want to do is just sort of walk people through some of the, not really tips and tricks of Azure Keyvault, but just some things that people may not be 100% aware of. So, and that number 2 will shock you. Yeah, that's just clickbait. That's just, don't worry about that. Also, some friends of mine, we actually started a new Azure security podcast. We're actually going to record episode 3 actually right after this session. So I'm looking forward to that. It's going to be about Azure Security Center. And so please, yeah, go ahead and go to the website there and sign up for the podcast. Also, I would like to thank, and I know you probably don't know the names, but Harvey Wilson and David LeBlanc. So Harvey is basically the lead on Azure Keyvault, and David LeBlanc is a whole friend of mine. He and I have written a number of books together, and he works mainly in crypto these days in Azure as well. So let me just get stuck into it. So again, for those of you not aware, so Keyvault is basically a service that we have in Azure where it can store keys, secrets, certificates, and so on. They're backed by hardware ultimately. They basically tell us and cipher HSMs It's actually really cheap, actually, to actually store secrets in Keyvault. It's actually surprisingly cheap. But ultimately, the nice thing about Keyvault is it becomes a single repository where you can have not just store secrets, but you also can store them securely and have audit policies and access policies around them to protect those secrets. So anyway, so sort of, number one is Azure Keyvault is not a silver bullet. I've talked to too many people, honestly, at Microsoft who have deployed Azure Keyvault, and they literally just said, well, just deploy your keys in Keyvault and everything will be secure. It's not as simple as that. It really is not as straightforward as that. It's certainly a convenient place to store keys and secrets. You've got this whole lifecycle management that can go along with that. So, for example, if you build you create a certificate, or you create a certificate sign-in request and get a certificate from a CA, you can handle the whole life cycle of that certificate. So as it's getting close to expiry of the certificate, you can say, with 10% of its life left, or 20 days of its life left, let me know, and either go through and reapply for that certificate, or re-enroll, or just let me know. So things like managing secrets, and when a secret becomes available and when it expires, versioning of secrets, that's all handled by Keyvault, and that's really fantastic, because it's certainly a heck of a lot better than doing it yourself. The problem with Keyvault, and it's not really a problem, but this is the realization that a lot of people come to, is that Keyvault really turns a crypto problem into an authentication and authorization problem. Just stop and think about it for a minute. If you got some secrets stashed somewhere, even if it's in some hardware, who has access to the information, or who has access to the operations that work over those secrets? So it's not a silver bullet, right? You're basically turning this crypto problem into an authentication and authorization problem. So you store an asset in Keyvault, at some point you have to access that secret, or you need to call an API that may access the secret. So the secret is not directly, not directly exposed. So who or what has access to Keyvault? And that becomes the ultimate issue. Every customer I work with, when we're talking about Keyvault, we spend a lot of time understanding who has access. What are the audit policies around Keyvault? What are the authorization policies around Keyvault? When it comes to things like processes in Azure, so for example, I don't know, let's pick on something, an Azure function. If you're familiar with AWS, it's like a Lambda. So I can actually grant that function access to Keyvault, or more accurate, I can say it has read access to keys, and that's it, nothing else. So again, you're turning this crypto problem into an authentication and authorization problem. A lot of people don't realize that. So I sort of mentioned here, here's an example. If I look at the access policies on this Keyvault, you'll see that I'm allowing, and by the way, random words is actually spelled like that on purpose, believe it or not. It's a long story. Basically, the story is I already had a function called random words that was spelled correctly, and I made another one called random words, and of course it can't happen because you can't have two functions with the same name, so that's what I did. But so you got this random words function, which could be written in, I don't know, C#, could be written in Java, could be written in JavaScript. But what I can do is I can grant that function what's called a managed identity, which is essentially a identity that is managed by Azure Active Directory, and the key that's associated with that, the secret, is managed by Active Directory. The application never sees the key. And then what I can do is I can grant that application, in this example here, so I'm saying this Azure function has the ability to get and list keys. And that's it. You'll see that for secrets, 0 permissions are selected, and for certificates, 0 are selected as well. You'll see that I'm down here. My account is actually the global admin, or the owner, I should say, for the subscription. And I would have, even though you can't see it because it's obscured by this drop-down box, I have all the permissions to manipulate secrets and all the permissions to manipulate certificates, including enrolling for certificates and so on and so forth. But this is really nice, because when random word starts up and it wants to reach out and pull a key, it can only read the keys and it can only list keys. It can't do anything else. If it tries to go and read a secret, say for example a SQL Server connection string, or some kind of other resource connection identification, it would fail. It can't read it. So it's a really nice example here of just sort of limiting access to to what this one particular application can actually do. Just about everything in Azure has this access policies over on the side, where you can set an RBAC policy at the management plane, so who can do what to the assets that are being protected within the resource. You should also restrict Keyvault to a virtual network. It's possible you can actually have a Keyvault sitting with its backside on the internet. Just click on always networks, all networks if you really wanted to. You can do that. I'm not saying it's a good idea, but what I can also do is I can set it to a private network. So there's some work I'm doing right now in this COVID-19 workload for a healthcare organization, and they have 5 Keyvaults, and there's a reason for that. But if you look at the way the network is set up, essentially the Azure networking infrastructure is using private endpoints, which means that the whole application that's running, including the Keyvaults, is essentially on the customer's network. It's just an extension of their own on-premises network, and the address ranges are their own private network, the whole 9 yards. So there's no way you can even get into the Keyvault unless you're actually on the customer's network in the first place. So things like Keyvault have their own little sort of mini firewall, sort of a lowercase f firewall, which essentially allows things like restrictions to specific IP addresses, those kinds of things. But yeah, I mean, one of the most important things here is to make sure that you do have a sort of some degree of network isolation. For those of you not familiar, you may be thinking to yourself, well, hang on, surely having a Keyvault with its backside hanging out on the internet is a bad idea. I mean, yeah, I mean, you could have a strong authorization policy around it, right? So, only authenticated and authorized users can actually even get to it. But with that said, if you absolutely want to make sure that you never create an Azure Keyvault with its backside hanging on the internet, the way you do that is with Azure policy. So I can actually have an Azure policy that says, if you create a Keyvault, it can never have a public IP address. And so if you actually try to create one, whether it's through the portal, whether it's through the command line, whether it's through PowerShell scripts, whether it's some JavaScript code calling a REST API, if it tries to create one with a public IP address, it just fails. And the error you get back is basically a policy violation. And you can set those policies at the subscription level, or you can set them at a resource group level. You can also set them at a management group level. Management group level is when you can have multiple subscriptions, wherever it makes sense. But most commonly it's at the subscription level. So that way, if someone even tries to create one, doesn't matter how they try to create one with a public endpoint, it just fails. And then you can also set those things up for audit rather than deny. But that's up to you. But obviously, deny is the most draconian. It will just not let you create the Keyvaults in the first place. On the topic of lifecycle management, you can actually create your own certificates. You can also issue them out of a CA. It's not actually in this UI here. I apologize for that. It's not in here. But there's a small set of CAs that we work with, and that list will grow over time. And so you enter your credentials for your account with that particular CA, and we'll go ahead and actually manage the life cycle for you. So when a certificate is about to expire, so for example, you could say 30 days prior to expiry, it will go out and reach and do the appropriate certificate request and issue a new certificate for you automatically, which is really kind of nice. So this is the one that a lot of people don't realize. Keyvault doesn't always store your keys in hardware, and that shocks people. Ultimately, it does actually store your keys in hardware, but let me explain. There's 2 versions of Keyvault. There's the standard version and the premium version. And frankly, the only real difference from your perspective is cost. Honestly, the cost isn't really that much, to be honest with you. But anyway, that's by the by. When you actually decide to deploy a Keyvault, you can either choose the standard SKU or the premium SKU. The premium SKU, your keys are in hardware. In software, in the standard SKU, the keys backing your keys are stored in hardware. But the keys are actually just stored with your subscription. Don't get me wrong, the keys are still backed by hardware. It's just one more level of indirection, that's all. And the APIs are the same, the interfaces are the same, the algorithms are the same. There's really no difference whatsoever, with the exception of the keys, in the case of the premium SKU, are actually backed completely in hardware. And it is a little more expensive, but honestly, we're talking cents, not dollars really. So as a general rule of thumb, software keys are used in dev and test, and then in production, you use HSM back keys or the premium SKU. Again, I'll be honest with you, it doesn't really make a lick of difference, really, because at the end of the day, the keys backing your keys are stored in hardware anyway. So it's not really the end of the world, but some people require their keys be in hardware, period. And in which case, sure, go ahead and we'll store your keys in hardware. If you look at the way the UI kind of changes, if you're using Keyvault, if I want to go and generate a key, I can choose RSA or elliptic curve and then the appropriate key size. You'll see that for the key type, there's two versus 4 different key types. For the standard SKU, you can do RSA or elliptic curve. And for premium, you can do RSA elliptic curve and RSA HSM and elliptic curve HSM. So those will actually be stored directly in hardware. If you create one of these, the RSA or elliptic curve, those keys are stored in software, but the keys encrypting those keys, the key encryption keys, are stored in an HSM that's managed by Azure. If you're using, for example, PowerShell, you can get a Keyvault key. So there's the Keyvault name, there's the name of the key. I can get the key and then the key type. And so, for example, for this one here, this CMK Auto 1 is, in this one particular Keyvault, is RSA. And I got another Keyvault here, which is hardware backed, and that one's elliptic curve HSM. So that's a key is actually stored in hardware. And by the way, if you do a dot key, you won't get the key. In this example, you will not get the key back. You get a key identifier back. In fact, in both examples, you don't get the key back, just the key identifier. Now, one thing I sort of already touched on this with Azure policy, you can enforce policy that says when you deploy a key vault, it must be in hardware. And that's represented through a JSON script. And basically what you say is, if all these conditions are true, product service type is key vault, and if SKU is not premium, then the action is to deny. And that's what's exactly going on here. I've tried to create a SKU, try to create a version of Keyvault that is not a hardware-backed SKU, and the validation phase, I said nope, and there's my I've called it won't work. Resource won't work was disallowed by policy, and the policy, if I go and look at it, is this JSON file that says it must be an HSM, and you can do as your policy for a huge swath of services that are built into Azure. So, for example, you could say, if you're deploying Cosmos DB, then you can only deploy databases in East US 2, and South UK, as an example. And so in the UI, if you decide to go and replicate that database out to, I don't know, South Africa, because we now have data centers in South Africa, it won't work, because that policy is a violation. You can do things like, VMs must sit behind load balancers. You can say only certain types of VMs can be used, right? So you may choose, some of the least expensive VMs and just say only these VM types are allowed. You can do all that through Azure policy, which is, Azure policy is like one of my favorite features that's built into Azure, because I can enforce these business requirements, as I said, sort of either at a subscription level or one level above that, which is a management group, which can be multiple subscriptions. Or I can even do it right down to a resource group. Just say in this one resource group, these are the policies that apply. So number 3 is there are actually 2 vaults in Azure. And actually, the second one's actually not called a vault at all. That's why I put quotes around it. But there are 2 products. One is Keyvault, the one that we know, which is the Talos and Cypher HSMs. The other one is called the dedicated HSM. So basically, this is, if you opt in for this, this is an HSM. It's absolutely yours. It belongs to nobody else. We will never process anybody else's secrets. This is 100% yours. It's a lot more expensive than Azure Keyvault, significantly more expensive than Keyvault, a ridiculously large amount more expensive than Keyvault. But for customers that need it, that option's there. I'll be honest with you, it's not commonly used, but the small number of customers that do use it are happy it's there, and that's exactly what they use. It has different APIs, different REST APIs, the whole 9 yards. It is a very different beast than Azure Keyvault. And my general rule of thumb is this last point. If you need to ask, you probably don't need the dedicated HSM. Different hardware, but it's there for very specialized purposes. And the customers that need it, again, are happy that it's there, but they're very specialized customers. So number 4, so Keyvault is interesting. It talks about keys, secrets, and certificates. And one thing that I've learned over the years, especially when it comes to crypto, is you have to be really pedantic with your wording. And Keyvault sort of exacerbates that because it has keys, secrets, and certificates. And they're not the same thing. They're never the same thing. I've seen people talk about, how do you protect a certificate? And the answer is you don't. People are aghast when you say, I don't protect my certificates at all. Well, what happens if it's leaked? I'm like, who cares? It's public information. There's nothing sensitive in there, and it's a digitally signed document. Who cares? It's nothing sensitive, everything in there is public. So, but how does SSL and TLS work? So are you talking about certificates or private keys? So we're talking about private keys. Well, we'll say that. A private key is not a certificate. And one thing you learn, especially when you're working with Keyvault, is to be super duper pedantic with your wording. I mean, how many people have you heard say, I encrypt something using SHA-256? It's like, no, you don't. You hash something with SHA-256. And it was like, well, you know what I mean. I'm like, no. I don't know what you mean. If you think you're encrypting something with SHA-256, then you're dead wrong. So you got to be really pedantic with your wording. And this is, Keyvault really raises that up because we do have the notion of keys, secrets, and certificates, and they are different things. Now, the keys that are stored by Keyvault are only asymmetric, and they're only elliptic curve or RSA. So if you want to do encryption, you can use RSA. If you want to do wrap and unwrap, you can use RSA. If you want to sign and verify, you can use RSA and elliptic curve. If you want to store symmetric keys, they're not stored as keys at all. They're stored as secrets and you'll see why in a moment. But this is incredibly important to understand. In Keyvault, we have this notion of these 3 different things you want to store. Keys are only RSA or elliptic curve keys. Secrets are basically kind of anything, to be honest with you. I mean, a SQL connection string, or perhaps a resource token for accessing a Twilio account. Whatever makes sense. And we don't really care what's in there, to be honest with you. There are size restrictions, but for the most part, you can basically stash anything you want in there. And then the last one is certificates. And certificates are actually an X.509 version 3 certificate plus its private key. And then the lifecycle management that goes on behind all that. If you're doing elliptic curve, you got a whole, if you're doing RSA, you got different key sizes you can choose from. If you're doing elliptic curve, you can choose different elliptic curves. This last one here is used by blockchain. That's why it's in there as well. So really important. Keys in Keyvault are only asymmetric. They're only RSA and they're only elliptic curve. And it depends on what kind of operations you want to perform. So if you actually look at the different settings that you have, different RBAC policies you have on each of these elements, you've got keys, you've got secrets, and you've got certificates. And if you look at keys, you'll see you got the ability to import, delete, recover, backup, restore, etc. But you've also got these cryptographic operations: decrypt, encrypt, unwrap, wrap, verify, and sign. So this is when, so for example, you want to decrypt something or encrypt something, encrypt or decrypt, doesn't matter. You pass it into Keyvault, and the key never leaves, right? So the encryption and decryption operations. So in the case of RSA encryption, it will encrypt using the public key. and then the decrypt operation will be with the private portion of the key. If you're doing a wrapping and unwrapping, basically the same. It will wrap it with the public key, and the unwrap operation will be performed by the private key. And then for signing and verifying, so the signing is done with the private key. So what happens is the hash will go into Keyvault as part of the REST API, and we will actually sign that hash with the private key. The private key doesn't leave Keyvault, and then just give you the result back. So you end up with a signature coming back, which is essentially a private key operation over the hash. So as you can see, those, and I appreciate the scroll bar down here, the drop down list box doesn't go further down, but this is the key settings are the only ones that actually have cryptographic operations. The rest don't. There's no notion of cryptographic operations on secrets, and there's no notion of cryptographic operation on certificates. But certainly on the keys portion, there are these operations. So what happens if you want to perform symmetric cryptographic operations? So the way you would do it is you would store a secret in Keyvault. So that would be your AES key, for example. You would derive a key from the secret, or use the secret directly, whatever makes sense for your solution. If you need to transport the key somewhere else, then you could wrap that using RSA, and then the other side could then unwrap it. And then all the symmetric key operations are actually performed in your code. So the symmetric stuff is not performed within Keyvault because it has no notion of symmetric cryptographic operations in hardware. They're all asymmetric. So as I've already touched on this, but for these cryptographic operations, they can be performed inside of Keyvault, so that private keys actually and public keys, although you're probably going to wrap those in a certificate anyway, those private keys do not leave the hardware boundary. This obviously assumes you're using the HSM module, right? You're actually using the premium SKU. But this is kind of nice, right? Because then you can just call using a REST API or a wrapper around it. You can call into there, and yeah, off you go. The keys don't actually leave the hardware. So if you look at these operations, you'll see there's actually basically they're just REST API calls that you're going to make that will actually do either do the decrypt operation. I'm just loading something up. I haven't already guessed. Need to find it. So yeah, you'll hear, here's the post operation. So it's the base URL to the Keyvault keys, whatever the key name is, whatever the key version is, then the decrypt operation, and then the API version. So there's one each of these post REST API calls for each of the appropriate cryptographic operations, and then the body will actually contain the relevant data. So before I move on, are there any kind of questions so far about what I've talked about?
Yeah, I think there's actually a couple of questions, Michael.
Sure. Yeah, far away.
So there's a question about whether Azure Keyvault has the ability to do crypto operations itself, so I don't have to pull keys from the vault via my code.
Yeah, that's exactly what this is. Yeah, but it's always asymmetric. But okay, yes, cool. Yeah, absolutely. Yep.
Perfect. And then the next question is, does Azure provide any professional services to help customers with setting up the Keyvault?
Absolutely. Give me a yell. If you have any questions, let me know. Absolutely.
Cool. Awesome.
In fact, I mean, that's what I spend probably 95% of my time is doing exactly that.
Perfect. Thank you.
That being said, it's honestly not rocket science. How long do we have? But I'll if anyone knows me, I'll just keep talking until I'm blue in the face, until you guys kick me off the stage. How long do I have? Because if I have time, I can give you a demo, like setting stuff up in Keyvault. Just so it's 2:20 Central right now. How long do I have?
We have about another 40 minutes.
Okay. All right. I'm trying to find my Keyvault code. That's all right. I'll find it. All right. So when you're doing crypto operations, let me just bring this up. I'm trying to find. I've got it over my GitHub repo somewhere. The code for doing this. Anyway, so when you want to do these crypto operations, For some reason, I don't understand why, but there's no PowerShell wrapper for calling into Keyvault, which kind of drives me a little bit bonkers, to be honest with you, because one thing that we do very well in PowerShell is wrap stuff into PowerShell to make it so much easier to call things. But anyway, you basically end up having to call the REST APIs directly. So here's an example in PowerShell where I've got a string, hello world, and then turning that into a series of bytes, and then turning it into a byte array. And then getting the key ID, and here I am building up the REST API call. I'm assuming I already have the bearer token in this code, and I'm going to use RSA OAEP, which is optimal asymmetric encryption padding. So we're building up our body now. We then convert that to JSON, and then we just call the REST method, and then what will come back is actually the ciphertext. So all the work has been done actually in the hardware, or in the case of a software version of Keyvault, it's still being done in Azure, and the keys are not leaving Azure, but it's just not being done in hardware. We've essentially got an emulation layer that's in software. Again, it's not like it's it's not super expensive at all. I'm going to be honest with you. It's just not to call Keyvault in hardware. The hardware version is really a sense. It's really a sense. But at the end of the day, if you're doing lots of experimentation and messing around and goofing around, then you may just want to use the software version, and then for production, actually go ahead and use the hardware version. So the next thing is from C#, there actually is a wrapper that's part of the SDK, the Keyvault SDK, which is just part of the normal Azure SDK. But the nice thing here is I can create a Keyvault client, and then I can literally just pass in my call, including my plain text, and it will actually give me a result back. Whoops. And that result will actually include the ciphertext. So I have found my code. It looks like I may have deleted it from my machine, but luckily I have it in my GitHub repo. So let me just go and download it. Oh, messing around. By the way,
Michael,
normally yeah.
While we wait, one question from the audience is, what kind of algorithm you use internally in the Keyvault to actually encrypt the keys?
It's RSA.
RSA.
Yeah, because remember, it's all cryptographic operations are asymmetric.
Yes.
The actual algorithm is RSA. So you're doing the classic public key encryption over the plain text, and then you're going to do private key decryption over the ciphertext, and then for signature operations, again, it will be RSA. So you'll do an RSA signature operation using the private key, the private portion of the key, and then you'll do signature verification using the public portion of the key.
Okay.
Gonna put it in there. That should do. I'm going to move along, and then as we get some more questions, because I'm just loading up my demo now on my other machine, or my other monitor, I should say. So the other thing to bear in mind is access control. So this is incredibly important. I really can't explain just how important this is. So access control, first and foremost, is absolutely critical on Keyvault. You've got to make sure that appropriate entities or appropriate users or appropriate principals are allowed access to the Keyvault or not. And basically, the general rule is deny, right? If you don't have access, you can't touch the Keyvault at all, or the entries in the Keyvault. The interesting thing is that the actual level of access control is actually at the Keyvault. Today, the access control is not at the secret level or the key level or the certificate level. So you can't put individual levels of access at individual sort of leaf nodes. It has to be at the Keyvault level. This is why I mentioned earlier that one of the things I was doing with this healthcare customer is they have five. One of the solutions I'm working on them with them on is on this COVID-19 workload. We have 5 key vaults, and the reason why we have 5 key vaults is, one, because it's cheap. That's number one. Don't get me wrong. If it was expensive, we wouldn't be using 5 key vaults. So it is cheap. That's number one, or inexpensive, I should say. But the other reason is because we want to segregate the application, because one part of the application will handle data that's more sensitive than another part of the application. And we don't want one part of the process being able to even access, let alone decrypt the data. So what we're doing is just saying, let's keep it real simple. Let's say there's only 2 key vaults. We've got one part that handles super sensitive data and then sort of smushes it down and anonymizes the data and aggregates the data and then throws it across to the other side. The data is still encrypted, and we still have authorization policies on both sides, but basically one side can't read the other at all, both through an authorization policy and also because they don't have access to each other's keys. And that's really important. But because the authorization policy is at the key vault, we need to have 2 key vaults. If the authorization policy was at the key level, then we could technically have 1 key vault and put an authorization policy on individual keys. But to be honest with you, as I kind of mentioned, it's not expensive. It really isn't. So it's not really a huge detail. But if it were expensive, we would definitely be considering using just 1 key vault if it was really expensive. But thankfully, it's not. So I'm working feverishly on my other monitor at the same time to get this code up and running again. So that's why many customers will have 1 key vault per application. Incredibly common to do that, because that way you can put a very fine level of granularity at the key vault. The next one is that logging in Azure Key Vault is not obvious. It really isn't. And to be honest with you, it kind of drives me a little bit bonkers that it's not obvious, but it is what it is. So you've got to go into Key Vault and then go to the monitoring and then turn on diagnostic setting. Once you're in the diagnostic settings area, you would then go and audit for audit events and metrics. So audit events are things like, Mary created this key from this IP address, or this cryptographic operation was performed by Jim Bob from this IP address, or this application read the secret from this IP address. Those kinds, at this time, those kinds of things. That's really important because you really want to keep track of who is doing what. So you remember one of the very, very earliest things I said during the slide deck was Key Vault takes a crypto problem and turns it into a authentication, authorization, and audit problem. And this is the audit phase, right? We've already talked about authentication. We'll touched on it. RBAC policy is what provides the authorization. And then finally, we have this audit policy, right? So I can actually see who is doing what. I can also stream the information out either to a storage account. So I could then suck that into, say, Splunk as an example, or DivvyCloud. I could stream it to an event hub. And then from there, I could say shoot it out to a SIEM. Or I could write it out to log analytics and then put all sorts of triggers and those kinds of things. So that's essentially and you can send it to all 3 as well. It doesn't have to be one or the other. But it's really nice you can get this spew of telemetry coming out to actually go ahead and respond to events. And you can also go and query it with using Azure Monitor. Look at the information that's coming out. So you end up with doing queries like this. So this is called the Kusto query language, Kusto. It's very PowerShell / SQL-esque. So I'm actually just reading Azure Diagnostics and where the resource provider is Key Vault, and it'll just give me a whole bunch of information, interesting events that have happened, both at the data plane and the management plane in this case, 24 hours. But I can set it to whatever I want inside of the actual query. So this is called Kusto, Kusto, and that's a query language that if you want to learn Azure, then you really need to learn Kusto as well. It's an incredibly rich query language for investigating logs, because as you can imagine, there's a lot of telemetry that's created when using Azure, both the data plane and at the management plane. So a quick summary. Actually, what I'll do is I'll just sort of walk you through creating a key vault and kind of what it looks like. But a quick summary. So first of all, Keyvault is not a silver bullet, and I really can't stress that enough. I've heard many people, including Microsoft people, say, well, just deploy Keyvault and everything's going to be golden. It's just not as simple as that, because you are turning essentially a crypto problem and making it a authentication, authorization, and audit problem, which is fine. I mean, that's completely fine. I have no problem with that, but people just need to understand that. That's that's kind of the main thing. Keyvault doesn't always store secrets or keys in hardware. It will often store them in software, but it's protected by a hardware key regardless. It always changes back up to a hardware key, always. But the nice thing about the software versions of key vaults is they're a little bit cheaper than the HSMs. There are 2 key vaults or 2 vaults. Frankly, as I mentioned, if you need to ask why you need the other one, then you don't need the other one. That really is, it's like the old adage, if you need to ask how expensive, how much something costs, you can't afford it. It's the same thing. If you need to know why you need the other HSM, you don't need it. Keys and cryptographic operations are only asymmetric. There's no symmetric cryptographic operations. That doesn't mean you can't do symmetric cryptographic operations. You just can't do the symmetric encryption and decryption in the hardware. It's done in your own software instead. Access control is at the key vault. That will change, but right now it's at the key vault. And again, you can create a policy that says, Jim Bob has read access to these keys, and that's it. Jim Bob, this application has read-write access to the secrets, and that's it. Nothing else. And finally, and sixthly, I should say, logging isn't really obvious. By the way, that was the number 6 that I added. I added that because it wasn't obvious, and logging information in Keyvault is critically important. I think you need to really understand, what's going on inside of your Keyvault. So with that, let me bring up my Keyvault, my dashboard, my Azure subscription. All right, so just to zoom it out a little bit. So I'm going to look at the key vaults that I have. I already have 3 installed. I'm only going to add another one. Actually, let me see. Let me go see if I've got my Azure policy on that prevents HSMs. I don't even know if I do. Let's look for the word vault. It is there, and I think it's assigned. Nice. All right. So here's my key vault. So you'll see what happens in a minute. So here's my key vault policy. You can ignore all this junk at the top, but this is the part that actually really matters here. Right here. The rest of it's just junk. Forget about it. If you ever create these things by hand, you don't need to worry about all this stuff, and then there's goo at the top. You don't need to worry about that. So there's a policy rule that says if all of these rules, so that if the field is of type key vaults, and if the SKU name is not premium, then deny. Like, you can't create one of these things. There's lots of other policy definitions. Let me turn that off. These are just some of the custom ones. Let's see what this. I don't even know what this one is. Let's have a look. Audit SSH authentication on new VMs. Let's see what it is. I don't even know what it is. Rule is not deployed. Oh yeah, whatever. Okay, here's the policy rule. So okay, so this is taking parameters. So you can have policies that also take parameters. There's a whole bunch of things. So it's basically, if I have disable password authentication set to false, and disable password authentication, lowercase false. Okay, not sure why, but okay. And if the publisher is 7i Solutions, I don't even know who that is. And if the image offer is whatever the heck that is, But it keeps going. Oh my God, it keeps going. Oh, I see. It's looking at all different kinds of specific distros. Oh, that's interesting. Okay, this is a terrible example to show because it's 2,000 lines long. I shouldn't have brought that one up. Let's ignore that for a moment. But anyway, the key thing there is you've seen that I got a policy in there that will deny me creating a key vault that's not an HSM based key vault. So if I go back into my key vaults, create a new key vault. Yeah.
This is Paul. I got a question for you. Is regarding the keys or the key vault, is there a way to enforce dual control? There are some compliance that requires that one person can't have full access to the keys versus just sort of splitting the keys up.
Yeah.
Is that an option?
So there's something that's very commonly done, and I'll show you some of the policies in a moment. It's very common to have, say, one or more entities who have access to the keys, but they can't create or delete keys, and they can't do HSM level operations, right? So you may be able to go and read keys, but you can't do anything else. Or you may be able to create key vaults or purge key vaults, but you can't do anything else. So we can actually separate the management plane from the data plane. So yes, but it'd be worthwhile looking at your specific scenario. But based on the question, I would just say yes. Yeah, there are ways we can segregate operations.
Thanks.
Okay, this is a test. I'm going to put it in, I don't know, South Central US. By the way, if you didn't notice, we just spun up just recently 2 data centers in South Africa to start helping workloads in Africa. Pricing tier, here we go. So I'm going to make it standard just for the moment. And I'm not going to bother too much about things like network access policies. But you can actually define the policies right here if you want. Or you can do it later, doesn't matter. And I'm also going to give it a public endpoint. Yeah, I know. You can give it a public endpoint, and you can restrict it to a virtual network, or you can have a completely private endpoint. You can do either 3. That is public, but you're going to probably put a little firewall in there that says only allow specific IP addresses access. So for example, you often see people who will have a firewall and have Keyvault perhaps listen only to the back end of the firewall, only accept traffic from the back end of the firewall, the private IP address of the firewall. Or that's a very common pattern. We see that often. Or I can actually put it on, even though this is a public endpoint, I can actually put it on my own set of virtual networks. And even though it says public endpoint, this is what's known as VNet injected, where it will actually inject this running process into your virtual networks. And then finally, private endpoints are completely private. So this is a true extension of your on-premises network. This does require some DNS work, but it's part of your private network at that point. You can't get to it from the public end. There is no public endpoint, period. So that's just, the most secure that you can sort of go up to. Well, I'm gonna stick with this because I'm being lazy. Tags, I'm not gonna worry with. Go and create it. It's running the validation on it right now, and it failed. And the reason is request disallowed by policy. I can go and click on that. It will. Well, I'm not. Okay, I'll log back in again. And then up pops the policy information. So I can actually see what the parameters were into it. I can also go and see the where are you? Oh, perhaps I can't. I can only see the policy definition. Oh, the policy text. That's weird. Okay. So anyway, so it failed. So now what I can do is I can go back and make it premium SKU, and let's go and review and create. Validation passed. That went past the Azure policy. It's now deploying it into my resource group. While that's going on, I can go and look at another. I can go and look at other key vaults that I have. Let's look at this one. So as you can see over here, I've got keys. I'll come to these in a minute. I've got secrets, and I have certificates. Here are so the key vault's deployed. Here are my access policies. So I'm basically the owner of the subscription, so I have full control by default. These here are actually applications. They're actually not they're not user accounts. So when you actually spin up a process, if I let's see if I can find one. I'm sure I've got an Azure function in here somewhere. So here's my test 42. If I go and look at identity, here we go. All right. So this thing has what's called a system assigned identity, and this is the object ID that's used. So it's what 2A31, and this is completely managed by Azure Active Directory. It's got nothing whatsoever to do. I do not control it at all. But I can turn that off, and now this has no identity whatsoever, and save it. So it's called my test 42. Right, so that's the name of the identity. I'm going to keep it turned on for the moment. So it's called my test 42, and this is the OID that's to do with it that relates to it. So if I go back to my Keyvault, and I go back to disk 42, and I go to access policies, you'll see I can go and add an access policy. Oh God, what did we say it was called? My test 42, is that right? There we go, my test 42. So that's actually not a person. That's actually an Azure function, and I can say that Azure function has the ability to get and list keys. It can't do all the other junk. Nothing. It can't do all the other stuff at all, unless say it can. Here are all the things that we can do on certificates. Let's say it can get and list those as well, and that's it. Nothing else. And go and add, and there it is. There is my test 42. So now when this Azure function goes to try to read that particular key vault, so the key vault has this URI here. So I can now go in and look at, say, a key. Let's say this key, and again, I don't actually get to see the actual key at all. I just get the key identifier, but here is the key identifier. So I can now go and use that key identifier to perform cryptographic operations or RSA related things on that key, and I can do it from my Azure function. And it will do it securely, because what would happen is when the Azure function goes to touch the key vault, Azure would automatically authenticate or not the Azure function, and then perform the authorization checks based on what I want to do. So if I was going to call that REST API that I showed you before, or just one of the REST APIs. So let's say I was going to call, oops, this ability here to, oh, actually, it can't do any of these, right? Because it's not allowed. But if I tried to call, call this REST API out of my Azure function, or using a wrapper that wraps around it with decrypt, it would fail, right? Because my particular, this particular application, if I go back to my application again, I'm sorry, I realize I'm jumping all over the show here. But if I go back to my app, right, so this application is my test 42. If I go back to my Keyvault, you'll see that go to, where are we, access policies. Oh, I didn't save it. Oh, what a muppet. I didn't save it. Let's do it again. All right, so we're going to do, actually, you know what? Let's allow this thing to do crypto operations, and that's it. All right, so now I can do, was it my test 42? Add, and this time save. What an idiot. Can't believe I did that. But no, I probably do that like once a week. Forget to save it. But now, so my test 42 has the ability to decrypting. So basically do all the cryptographic operations. But it can't list the keys. It can't get the keys, or the key identifiers, I should say. Yeah, so now if I go and call that Azure function, my test 42 tries to do one of these operations, it will succeed, right? Because this application has the appropriate RBAC policies on the Keyvault. So, or by the way, you're probably not going to call those REST APIs directly, right? You're probably just going to use some wrapper. Here's the code that I was going to demonstrate, and I really apologize. I thought I had this set up because I have done this demo before, but here I'm creating a Keyvault client. It's connecting to Keyvault. So that's wrapping some REST APIs. Then I'm getting the key by its name, but again, you don't get the key. You get a key identifier. Then down the bottom, I'm saying I want to do some crypto goo. I'm going to use RSA OAEP, which is the optimal asymmetric encryption padding. It then actually calls the encrypt method with the algorithm information and the text. That work is all done. So this work here is all done. This is a network call, a REST API call that does all the appropriate crypto goop inside of Keyvault. And then I just do the reverse operation down here. So I apologize for that. I should have set it all up. I thought I had. So that's basically Keyvault kind of in a nutshell. I realize it's a bit of a whirlwind tour, but any questions or comments or insights or, oh my God, I'm petrified of using Keyvault now? Nothing at all. Anybody still there?
Hello?
Hello, I can hear you. Yep.
Yeah, there are questions. Let me see. One of the questions that came up is about the REST calls. So
I'm sorry, about the what? The REST what?
the API calls.
Yeah.
The barrier token.
Yep.
So what do you do with that barrier token? I mean, how do you protect it?
I guess the question I'm asking, sorry, I couldn't get my microphone on earlier. I'm the one who asked the question.
Mm-hmm.
Basically, you still have to have credentials, right, to get the bearer token to then use that to do the rest calls to get your
correct,
right?
Yeah.
Well, how do you protect those credentials then? If you have an application, let's say you have an application that you're storing the connection string in the Keyvault, and so the application needs to go get the connection string, and so it calls those REST APIs. It's got to use those credentials. So how do you protect them?
So it depends what the credential is, right? If it's an application, so for example, this my test 42, the credential is completely managed by Azure Active Directory. You do not see you will never see a credential. AAD takes care of everything. When this puppy starts up, when this Azure function starts up, it is automatically logged on to Azure and will have its own bearer token. You will never see it. That's the beauty of these PaaS environments, right? You never see that information. So it's completely transparent and incredibly safe, because you will never see the bearer token ever. It's all taken care of by the Azure Fabric underneath you. Now, if you decide to make a call out from the Azure function to some, over a salty piece of string to some endpoint that's not protected, then the bearer token is in the clear. But that's your own stupid fault, right? Because you shouldn't be doing that. But if you're doing like a logon from a user, for example, then it's a classic problem at that point. It's like, so do I log on with my password that's in my head? I mean, do you store the secret somewhere? That's completely up to you. But I mean, there's an example I would give here. If I run this, it will actually log me on. The UI will pop up. The Azure logon UI will pop up. Just like, are you guys still seeing my screen? Yeah. I mean, you'll basically see something like that come up.
Yeah,
right. So I choose my account and then log on.
Michael, do you have any anti-patterns or common mistakes that people usually do when using the Vault?
Yeah, I would say the big one is constantly hitting Keyvault. Right. If you're running a PaaS environment and you need to pull a secret out, pull the secret out and cache it. Because in a PaaS environment, nothing has malicious code, doesn't have access to your memory space, period. It just doesn't. An attacker would have to be inside an Azure data center, would have to know where in these millions of racks your code is actually running, and then connect a debugger to it. So the bar is ridiculously high. So in general, I've seen people hit Keyvault all the time. Just think about how you can optimize that, right? And so, can you pull the secret in once and perhaps refresh it every 60 minutes, as opposed to hitting it 10 times a second? It's not designed to be a massive volume device. It's not like a web server, right? It's designed to handle thousands and thousands of incoming connections per second. It's just not designed to do that. Don't get me wrong. I mean, it can do thousands of operations a second, but they are throttled. So don't do that. So generally the anti-pattern is hitting Keyvault all the time. Rather, it's better to hit it once, cache it, and then perhaps every 60 seconds, refetching it or something. The biggest mistake people make, to be absolutely frank, is they get keys, secrets, and certificates mixed up, which drives me bonkers. But that's just me being a crypto wonk.
Well, Michael, it's been fantastic. Cassie, any other questions? Cassie, you're on mute.
Thank you. No, I was going to ask if anybody has any other questions.
All right.
Guess not.
So, Michael, again, thanks for taking the time to share your knowledge with us. Hopefully, this was enlightening for a lot of people. It's really great to finally get you out here, and let's, as you said, reduce that 10-year window. Maybe in a few months you can come back and talk about something else.
Yeah, you bet. Absolutely. Love to do it.
So for all of our participants, I didn't mention this in the beginning, but maybe you're not aware, but OWASP is a great organization, and membership is only $50 US. So all the money you're saving on gas and transportation, put that towards a membership and join the community. Join OWASP, owasp.org. We'd be happy to have you, and we look forward to more meetings and more great speakers, and the day that we can actually have a nice dinner together as well. So everybody stay safe out there, and we'll see you next month for a wonderful presentation from Jeremiah Grossman. Till then, stay safe, as I said. Bye-bye.
Thanks, guys. Bye.